Well, the power rule for exponents gives us a time when we can actually multiply exponents together. Now, if you'll remember, in our last section, the first property of exponents we learned was what we called the product rule. And that said if we were taking x squared times x cubed, our answer was x to the fifth because we could simply add the exponents together. So there's a time to add exponents together, but there's also a time to multiply exponents together. How do you know? Well, you've got to have an exponent outside of parentheses, and in a way I guess we could say this exponent doesn't have its own base. It's telling you to do something to the base that's inside there. And what is that? Well, to get the answer, you can literally just take m times n, or the inside exponent times the outside exponent. All right? Let's look at some examples of the power. X cubed squared. Okay, that's what this problem says right here. Now we know squaring means that you're supposed to take what's inside the parentheses and multiply it times itself, right? And so this is x cubed times x cubed. Squaring means to multiply by itself twice. And now, if we applied the product rule, we're supposed to add those exponents together, aren't we? So 3 plus 3 is 6. Well, what's 3 times 2? It's 6. So x to the 6th is the answer here. So without writing this intermediate step, we can come up with x to the, what is it? 35th power, because we're simply going to multiply those exponents together. This 7 says we want to do what's in here 7 times. So there's going to be x to the 5th, 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 and so on. It's going to end up giving you x to the 35th power. Well, sometimes you can have more than one base inside the parentheses. Here we have an a as one base to the 3rd power, and we have a b as a 2nd base to the 4th power. So in order to handle this problem, we need to make sure that we multiply the outside exponent here times every exponent inside the parentheses. That means we're going to end up with a to the 15th and b to the 20th. We have to take 5 times 3, and we have to take 5 times 4. So we're still using the power rule, though. All right? Still using that, even if there's more than one base inside the parentheses. Same thing. We've got more than one base in here. We've got a 5, and sometimes we call that a coefficient. All right? Don't let that word throw you. And we've got an a. Now, the mistake that a lot of people make here is they think that the 5 doesn't have an exponent on it. But the 5 does have an exponent. We could write that as 5 to the 1st power. And even if you ever see an x, just a plain old x with no exponent on it, that exponent of 1 is there. And you have to think about that. So now, I need to take this 4 and I need to multiply it by 1 and by the 3. And so this would come out to be 5 to the 4th times a to the 12th, and your calculator would tell you that 5 to the 4th is 625 a to the 12th. And that would be the simplified answer. Okay? Hey, how many bases are inside this set of parentheses? Well, an x, a y, and a z. What's the exponent on the x? Well, I hope you say 3. What's the exponent on the y? I hope you said 1. And of course, the exponent on the z is 5. And so we got to multiply every exponent in there by this 4. X to the 12th, y to the 4th, z to the 20th. Okay? And one last one. Now, we've got a negative number with an exponent of 1 inside the parentheses, and we've got an x. So now I need to multiply that outside power. And so this is going to be negative 4 to the 3rd power. That negative sign goes with that 4, and then this is going to be x to the 6th. So now that means negative 4 times negative 4 times negative 4. That's going to give you negative 64 x to the 6th. All right? If this would have been an even number, like a 2 or a 4, you would have ended up with an even number of negative signs, and the answer would have changed to positive, wouldn't it? All right. Hopefully that'll help you handle some of these power rule problems with exponents. Good luck.